On the rear wheel of the bicycle, the drive chain runs through this set of sprockets or cassette set. The cassette set is mounted on the hub, freewheeling. In order to achieve maximum drivetrain efficiency, that is to say to cycle with as little effort as possible, this needs to be rotating as freely as possible and with as little friction as possible. I hope that makes sense for drivetrain efficiency. Unless you really like the bicycle to be an exercise device or a torture device, depending on your philosophical bent. So, because water can get into this underneath this cassette set into the hub really easily, the hub needs to be packed with grease, fresh grease, to seal enough so water can't get into it. Once water gets into it, corrosion sets in, and corrosion will be a source of unnecessary friction. So periodically this needs to be taken apart, cleaned, re-lubricated, reassembled. In this video I'll show you the parts, I'll show you how the parts interact, I'll show you the tools needed to take it apart and get it done, and I'm going to do a dry fit to see how these parts interact with each other. That is, without grease, and yeah, it's just going to be a show and tell on how the ratcheting components work inside, where the bearings run and everything. I want to start with the make and model of this hub. This hub is a design that's from the 1970s, so at this time it's about 40-year-old design. The bicycle itself is 30 years old, made in the 80s. The maker is Suntour for the entire hub, and the make and model is also visible on this lock ring. Let me just put it down on the table. So if you know exactly when this Suntour Perfect model was manufactured, do let me know in the comments below. There is a company logo there on this lock ring, as well as two letters here, ZI or ZI, are visible there. Otherwise it says Maida Industries Limited, Japan. So that's the make and model of this hub. I want to point out that the part of the hub that's involved in mounting the cassette set has nothing to do with the part of the hub that mounts the axle. The axle is still inside the hub and is rotating right there. You can even see through it. Now the axle is bent, that's another thing, don't worry about that. Where the cassette set mounts here on the outside of the hub is completely independent from the internal surfaces of the hub that interact with this axle. Okay, so I hope that makes sense. I'm talking about, in this video, the outside surfaces of the hub, not the inside surfaces of the hub that interact with the axle. And through the axle, through that hole that you saw, this cam lock goes through, so that's how it mounts on the frame. Fairly straightforward, yes? Let's take a look at the parts here, just a quickie overview. This is all the parts you see. The cassette set, the lock ring that we looked at in some detail, two flat, really thin washers, two of these engagement pawls, I'll give you close-ups on it, two sets of bearing balls, hardened steel, 1/8 of an inch in diameter, 42 of these and 36 of those. One set of bearings, two sets of bearings, because this cassette set runs on two sets of bearings with loose bearing balls. With I'll show you the raceways and where these bearing balls go. In terms of tools, this lock ring needs to be removed. It's threaded, and that was a good left-hand catch, yes. And this is threaded backwards, meaning it was, to remove it, it had to be rotated in this direction. It was rotated using a soft nail, just a common nail made of really soft low carbon steel. This is a forged high carbon steel, really durable, and so with a soft steel nail this needed to be rotated this way, clockwise, to remove it. It was tapped with a hammer. You can see the deformation on the mild steel nail point That's what happened to it. That's fine. This will deform, mild steel or low carbon steel. This will not deform or shouldn't deform if you rotate it in the correct direction. And this is rotating for removal clockwise. This mounts on this threaded surface of the hub here. I'll just show you quickly. So to put it on, it needs to rotate counterclockwise like this. There we go. So that's how it goes on. Yes, fairly straightforward, and that height comes off clockwise. Now I want to point out that in order to set the torque, because I don't really have the appropriate tools for it, and neither does the bicycle shop nearby, or two of them, so take a look at the alignment of some of these marks on this lock ring. You can see the company logo here, and when it's tightened, its edge here just happens to line up with this notch here in the hub. So there's one notch here and another notch in the 6 o'clock position right here. There. Now the letters were covered with too much rust and crud and whatever, and I couldn't use them as a reference line, but setting torque this way is a valid way of setting torque. So this was rotated until the edge of this circle here lined up with the edge of this notch in the hub. I hope that makes sense for torque setting. And again, not insulting your intelligence, but this removes clockwise, so don't rotate it in the wrong way. You're gonna be going nowhere with it. So let's take a look at the bearing, how the bearing works. And there are two bearings inside this cassette set, and they run on two raceways, or yeah, two raceways, we'll go with that. I needed these tweezers. Oops, my tweezers is magnetic to control these bearing balls. They were washed in a non-specific cucumber jar or something like that, pickle jar, with some lacquer thinner. They are shiny, highly polished. They are not pitted, not chipped, not cracked. They are in good condition. If you lose some of these, they are still widely manufactured. They are 1/8 of an inch in diameter. Let's measure one quickly. Why not? Whoa! There, 1/8 of an inch. Alright. Now, these bearing balls need to be placed one by one. I'll show you how. But they run, one of the surfaces is inside the hub here. I know some parts of the hub is still on the bicycle, but some other parts of the hub, some other parts of the raceway are right here on the cassette set. So you can see this polished surface here. This is the raceway. This should also be, ideally, free of pitting, corrosion, discoloration. If it's like this, polished, that's nice. Now, where rain can get into it really easily, I'll show you. It's fairly straightforward. So rain runs down here, and you can see the bearing balls are on the inside there, and you get the idea how the rain can get into it really easily right here. Okay, so that's why this needs to be packed with grease, but only not the whole thing, the whole inside of this cassette set packed with grease, just here where the bearing balls run. The second surface, the second raceway to match this raceway, is right on the hub. This polished surface you're looking at is the raceway here. Again, is free of pitting, free of corrosion. It looks like it's in a really good condition. The rest of the hub here, it doesn't need to be greased, and you can see some corrosion on it. That's not interfering with and is not a source of friction, because where the hub rotates is here on the raceway. I hope that makes sense. So that's why I'm not too concerned about this surface here or cleaning it. You can see it's been coated, anodized, or some such thing by Suntour. That's how it was manufactured. So this kind of pitting, whether it's dirt deposited on it or corrosion byproducts, I'm really not too concerned about this little black something here. So that's the raceway on the hub, and that's the raceway for the bearings inside the cassette set. The other raceway for the second set of bearing balls, 36 or 42, go into this larger bearing surface, and the 36 of them, and I really hope I didn't lose any of them, go inside the hub on this side, right next to this serrated surface here, right here where my nail runs. This is the raceway. It's not entirely clean, there is some dirt on it, but other than that, it's not pitted again. It's clean, almost. It's not corroded. There, a little bit of dirt. I'm gonna wipe it away. But this is where the bearing balls run, so that's where they need to be going back. I'll show you how. The serrated surface inside the hub, as well as this raceway here. Oh, I forgot to mention, the second raceway for this bearing here is the lock ring itself. The underside of the lock ring is profiled in a way that you can see the raceway on it. This is the surface where the bearing balls run, and this surface is also looking really good. It's not flawless. There, how do I focus the camera? There, something like that. It's a curving surface. There. It's not flawless, it's got a little bit of discoloration on it, but right in the middle is polished and it's pretty good. So, this part here, where the raceways are machined into the hub, is in a forged sleeve. So, this is a forged component here that goes through the whole cassette set and comes out here. So, this metal here is different from this metal. This is a coated and stamped metal, and this is a forged metal. Forged high carbon steel, really durable for the bearing surfaces. And on this sleeve here, these sprockets are threaded onto and are fixed in position with some thread lock. So Loctite red thread lock. You can see that the sleeve on the outside here is threaded, and that's how the biggest is threaded onto this sleeve here and ran all the way down here and is tightened, and then the next one, and the last one is also threaded onto this sleeve here. Okay, so this forging here in the middle, the condition of this is really important. This, in theory, could be replaced and separated from the stamped sprockets that are mounted on it to make this cassette set. So it's made of 6 pieces of stampings and 1 sleeve in the middle, onto which these 6 sprockets are threaded and glued in place with probably red Loctite. Okay, now this serrated surface here in the middle works with these engagement pawls. This is how these little guys look like. There's a groove on one side of them and they are curved on the other side. There is a bulging end to it, and which is rounded, and there's another rounded end to it as well, but that's not bulging. So you can see wear here at the tips of it, and I'll show you where they go. They live inside the hub on this particular in this particular recess, and the groove is where this spring is gonna run. This is a piece of spring steel. This is pivoting up on this pin here. This little spring is running in this groove here, which I cleaned, but I did not remove the spring itself in its entirety. I just left it in there. So I'm gonna show you how this engagement pawl goes in there. It's really easy to place it. Something like this. It's in there, and then fold it up, and I'm gonna fold down the spring, and I'm gonna need 2 hands for this, and we'll put you on a tripod, but you need to fold this spring, pull it sideways and fold it, or put it underneath this pawl so that the spring's end is in the groove. I hope that makes sense. And I'm gonna do that. Just put you on the tripod here, bear with me. So just like that, needs a few seconds, and that's it. And that spring is keeping this tab upright or up in the air. Same for the opposite side. I'll get you a close-up on how these look after assembly and how they work with the serrated surface inside the cassette set. Just give me a sec here. Nice. So that's in place. Good. And actually I'm gonna put it down horizontally because that's high. That's how I'm gonna need it. So this is how they look when they are assembled flawlessly, and probably with good enough light you can even see maybe that the spring is actually inside the groove. It's really difficult to film it, so we'll just leave it as is, but I know they're inside. How they work with the serrated surface is fairly straightforward. Just like that, they go together, and in this position, now it's making the familiar clicking sounds. You can see motion on both of them. So this is freewheeling, and when you put force on the pedal and pedal forward, this is what happens. Now out of the 2 of them, only one of them is holding firmly. In this case, the upper one there at around the 12 o'clock position. So you can see that the nose of the pawl is hitting one of the serrated surfaces inside the sleeve, inside the cassette set. And if I freewheel just a little more, 1 click, there. Now the other one at 6 o'clock position, that's going to be engaging and transmitting drive forces, rotating the wheel. Now the other one is engaging, and that's how these 2 work. 1 click, the other clicks. 1 clicks, the other clicks. So that's how these work. Now if you take it apart like this on a horizontal surface, when this is still full with these bearing balls, that's gonna be a good work surface for you. In terms of assembly, this is where you start. You need to lubricate this raceway here generously with some grease. Put some grease on it, or put some grease on your hand and lubricate it like so. I've got some Yamaha marine grade grease and some Kawasaki something, so one of those will work. Just needs to be some general purpose grease all around it, really generously. And with your greasy finger, grab one bearing ball, it's stuck on your finger, and stick it in the grease. And then the next one, and the next one, and the next one, until you make it's gonna look like a pearl necklace all around the hub here, with all the steel bearing balls, all 42 of them sitting here on the perimeter. Once you have the 42 in place, you also need to grease this raceway here. Strongly recommended that it be really thorough, and just drop it in place, and it's gonna be, you'll see, spread the grease a little bit on the bearing elements, and it should be fine. Of course, you need to lubricate the pawls as well as you put them in, or before you put them in, so that's gonna be greasy and everything as it should, so that this not be corroding. and then you put the 36 smaller bearing balls the same way. Put some grease in here before you put this cassette set on this set of bearing balls. You need to fill it here with grease for the other bearing surface there. And once it's in place, you need these two washers that I didn't say much about, but this one here, they only go to one spot. So this one with the tabs goes in there like so, and then on top of it, this one with no tabs is placed, and then grab the lock ring, and it should thread in place there fairly easily, tightening it counterclockwise again. And you can see right away that when the thickness, due to the thickness of these washers, when this is in place, the edge of this company logo does not line up anymore with the edge of this tab here, because this is how much I need to tighten it, not with the tweezers but with the nail and the hammer. A few taps in this direction and a few taps in this direction until I have this alignment here, the edge of this lining up with the edge of this right there. So about this much forward rotation is needed. So I'm going to take it out now, because I want to point out one more thing. When the lock ring is in place, you can see the tab on the washer right there. So that's important to notice or note, because that's what I mean by water can get into this hub really easily, can corrode things and be a source of friction, and then it's not really efficient. It's going to become an exercise machine. One more thing I want to point out is that when the bearing balls are all in place and the lock ring is in place and the two washers are underneath the lock ring, that this is still going to be moving a little bit. It's going to have a little play sideways. Of course now has a lot of play in it, but I wanted to show you this way to maybe not exaggerate it, but you get the idea that there's going to be some play on this, which is okay and is necessary to run the cassette set on the hub. But this clearance is also a source for water to come in, so that's why it needs to be really well packed with grease. And some of this clearance and some of this wobble motion is okay with the hub and the cassette. So that's how they interact. And that's all the tools that are needed. Lastly, I want to mention that I didn't have the proper tool for this lock ring, but if you do have some, the dimple to dimple distance on this thing is, and let me just set it to millimeters, is about 30.5 millimeters. When I getting there, 30.5 is somewhere there, close enough. So if you look at the spurs and the alignment on the caliper, so that's about halfway there, and maybe okay there, about halfway to halfway, or center to center, about 30.5 millimeters, or 1.2 inches, or yeah, that fraction. I guess we can go down just one notch, yeah, or maybe two, 1 3/16, something like that. 1 3/16 seems to be working with this. So if you have a tool with that can remove this lock ring instead of nail and hammer, yeah, go for it. That's the size of this lock ring. Maybe this dimension helps date this a little more accurately than designed in the 70s. But so if you can help, put your ideas in the comments below. Thank you very much for watching, and have fun cycling.